Hello and welcome to the lecture on MOSFETs. In this lecture, we will see the types of MOSFET and their working and their IV characteristics. So, firstly, the invention of MOSFET. This MOSFET was invented by Muhammad M. Atallah and Dewan Khan at Bell Labs in 1959, and it is first presented in 1960. So, here is Atallah and Dewan Khan. So Muhammad Ematullah, he is a Egyptian American. So he was born in Egypt and studied there, and then he went to America to work at Bell Labs. And similarly, Dawon Kong, he was born in Korea, and later he went to work in the Bell Labs, and so they become Egyptian American and Korean American. So these are the two people who has invented MOSFET in 1959, and it is presented in 1960. Now, next introduction to the MOSFET. So, this is a MOSFET device, which you can see here. But the MOSFETs that are fabricated on IC is different. But here, this contains a lot of MOSFETs which are connected in parallel to carry the high rating and yes. So it is a basic building block of modern electronics and the most frequently manufactured device, as you know today. And it is the dominant semiconductor device in digital and analog integrated circuits. So in any IC, we find billions of MOSFETs fabricated. It is estimated that a total of 1.3 into 10 power 22 MOSFETs, these many number of MOSFETs were manufactured in between 1960 and 2018. So you can imagine how much important the MOSFETs are. Like you can't even imagine this number. It is very high. So the name metal oxide semiconductor. So here it typically refers to the metal gate. So gate is made up of metal, and also we use a insulation between gate and the substrate. So that insulation is basically oxide. So that's why it is called metal oxide semiconductor. And the semiconductor is typically silicon. Now here types of MOSFETs. So we have two types of MOSFETs. One is DE MOSFET. So it is basically these are all belongs to DE MOSFET. So here we can see substrate, P-type substrate. Basically it is an N-channel MOSFET. So here for DE MOSFET, physical channel is present, and these two N's are highly doped. And the P-type substrate, we have source, drain, and gate. And gate and substrate are separated by insulation, that is silicon dioxide dielectric layer in between. And there is physical channel present here. And the gate is, as you know, metal layer, because that's why MOSFET is called metal oxide. So here we are using the gate. Now, so its symbol is this. So here the space represents the insulation, like both gate and these are electrically separated because of insulation. And the arrow now, and this is the ID, and for N channel, this is the symbol with respective, uh, ID. And the same, this is another diagram of the same DE MOSFET. So for DE MOSFET, we have, sorry, this is actually this is N channel DE MOSFET, whereas this is P channel DE MOSFET. So here this is N substrate, and P plus and P plus instead of N plus and N plus, and P channel. And for P channel MOSFET, the arrow is opposite direction, as you can see here. So these are the two P channel and N channel MOSFETs of DE MOSFET. the other type of MOSFET. So let's see the working of DE MOSFET and then let's move to the another type of MOSFET. Now the next is the working of DE MOSFET. So here in DE MOSFET we can see the structure. Now this DE MOSFET, it can operate both in depletion mode as well as enhancement mode. Now when the free electrons flowing from source to drain, it must pass through the narrow channel between the gate and the p-type substrate. So as N channel is present, then these current can flow. Now a thin SiO2 layer is acts as the insulator, so the gate is insulated from the channel. So now in case of DE MOSFET, as we have physical channel, that is N channel is present, when we apply negative voltage. So this is the case we are explaining for N channel MOSFET here, but the same applies to P channel. The only thing is that when we mention here negative voltage for N channel, in that P channel case, it will be positive voltage. So here we are describing total in terms of N channel MOSFET because this is the most prominent one. So what happens is that when we apply negative voltage to the gate, it will operate in the depletion mode. So and when we apply positive voltage to the gate, it operates in the enhancement mode. So for depletion mode, when we apply negative voltage, it will repel the so the voltage is applied between gate and the source VGS. When negative voltage is applied between gate and source, so the negative voltage comes at this gate terminal. As this is negative voltage, the negative will repel the free electrons present in the N channel. So this will result in the formation of positive ions. That is, when the electrons are depleted, positive ions are formed in the N channel. Therefore, as the negative voltage repels the number of free electrons, the current conduction would be reducing, which means that the electrical resistance of the device increases. Hence, as the negative voltage increases, the resistance will increase and the current will decrease. The current between the drain to source will be decreased. So now here the action of negative voltage causes depletion of the free electrons. Therefore, this mode of operation is called depletion mode. And in case of enhancement mode, we apply positive voltage at the gate. So when we apply positive voltage at the gate, what will happen? Negative charges are actually induced because the positive voltage will, on one side, it will induce negative charges on the other side. So therefore, total number of electrons in the channel will be increasing, and because of that, the conductivity will increase with positive voltage. Whereas with negative voltage, resistance increase. Hence, the greater the positive voltage, the greater will be the current through the drain to source. So now by controlling the voltage at between gate and source, we are between gate and source by controlling the voltage, we are controlling the current through drain and source. So that is why MOSFET is called a voltage control device, because we are controlling the voltage uh, to to control the current. We are modifying the voltage. So it is a voltage controlled device. Hence, when we apply the positive voltage, it increases the conductivity. Therefore, this mode of operation is called enhancement mode because it is enhancing. Now you can see the IV characteristics of DE MOSFET here. So for MOSFET, we have two types of characteristics. One is drain characteristics and the other one is transfer characteristics. Both are important. So in drain characteristics, we plot between drain source voltage VDS, as you can see here in the x-axis, drain source voltage VDS in volts, with drain current ID in milliamperes. So as the current is in the order of milliamperes, so generally we plot between milliampere. Now, when we do that for different VGS, so depletion mode happens when VGS is negative, that is below 0 volt, and enhancement mode for positive voltages. So when we vary the drain to source voltage, we get uh, curves in this fashion. So the current increases and it saturates for a particular drain to source voltage. And in case of transfer characteristics, that is, we are plotting between VGS and drain current. So here, instead of drain source voltage, we are plotting VGS, and the uh, we have seen the depletion and enhancement mode. For positive VGS, we have enhancement mode, that is current is increasing. And for negative VGS, we have to see like this. That is when negative voltage is increased from zero, the current keeps on decreasing and it comes to a particular value and remains constant. So this is the transfer characteristics. Both are important in case of MOSFET. Now the another type of MOSFET is enhancement MOSFET. So previously we have seen DE MOSFET. Now we are seeing enhancement MOSFET. This is another type. And in enhancement MOSFET also we have N channel and P channel. So in the enhancement MOSFET, there is no physical channel present, unlike DE MOSFET. So here there is no physical channel present, but by applying proper voltage, the channel is induced. Now for N channel enhancement MOSFET, you can see we have P type substrate. For always remember, for N channel MOSFET, E MOSFET, we have P substrate. For N channel MOSFETs, we have P substrate, and for P channel, we have N type substrate. And we have highly doped N layers and gate similar to the previous DE MOSFET. The only difference is no physical channel is present here. Similarly, this is P channel E MOSFET without the physical P channel present, and these are the symbols here. See, compared to the previous one, now we see this space. So this line is broken here. So this broken represent there is no physical channel is present. That's why these are three lines here instead of single one. Now this is for N channel and this is for P channel. This is a symbol for P channel. So here basically we have three terminals, and in some cases we can also represent the fourth terminal, that is body terminal. Either we can represent the body terminal or we need not represent like this. Here we have, so basically the body is connected to the source. Okay, so you can, instead of putting the body, you may also connect these like this. That is, the body terminal is connected to terminal, so symbol can be like this. As you can see here, the body terminal is connected directly to the source. So the same thing you can do here, but be aware of the arrow between N channel and P channel MOSFETs. Now the working of enhancement MOSFET. As you know, there is no physical channel. We have to the source, the substrate extends completely, so there is no channel, and we have to apply proper gate voltage to form a channel, and this is called a induced channel because we are inducing by applying the voltage uh, between the source and uh, drain. We are inducing the channel, and we are applying the voltage between gate and source. So there should be a minimum value of VGS for creating the uh, channel. So that minimum voltage is called threshold voltage. And for a N-channel device, it requires positive voltage. So for we are doing the analysis for N-channel, but in case of P-channel device, we have to apply negative voltage. So for N-channel device, when we apply positive VGS, uh, and that will create the channel. Now for N-channel MOSFET, the VGS should be greater than VGS threshold. Uh, sorry, I mean to say that when VGS is less than VGS threshold, the channel is not induced. Only very few electrons are thermally produced, so that the drain current is almost zero. So there is no channel induced. Only very few electrons are by default present because of thermal energy, and that doesn't yield any drain current. Hence, the E MOSFET is off under this condition. So when VGS is less than VGS threshold, the MOSFET will be under the off condition. And when we increase the voltage to greater than threshold, that will induce the channel and the current starts to increase with the voltage. Now, as the gate to source voltage increases, the drain current also increases, and as the channel becomes wider and saturates at a particular voltage called pinch off voltage. So the current will increase, but it doesn't increase indefinitely. You can increase the VGS up to a certain voltage VP. Till then, the drain current will increase, and after that, it will saturate. So this you can see here IV characteristics of E MOSFET. It can be classified into three regions: cutoff, saturation, and ohmic. So what happens in ohmic is that the current increases linearly, and after that it saturates. So basically, when the voltage is greater than the pinch off voltage, the current saturates. So that is the saturation region. Prior to that is ohmic region. And when VGS is less than VGS threshold, that there will be no drain current, and that is cutoff region. So similarly, we have seen previously there are two characteristics. One is drain characteristics and transfer characteristics. In drain characteristics, VDS versus ID, and in transfer characteristics, VGS versus ID. And here you can see that VGS is kept on increase, and after a certain positive voltage, the current starts to increase. So here you can see that from this graph, in this particular case of device, the threshold voltage is like 2 volts. For some other devices, it may vary based on the device. But for this particular graph, you can understand that the threshold voltage is 2 volt, and it kept on increasing as the VGS increases, and it later it will saturate. So this is about the types and working and the characteristics of MOSFET. Please subscribe my channel to get more videos. Thank you so much for watching this video.